Hey everyone, welcome to another session as part of Craft series. In today's session, I'm going to cover how effectively you can use in-memory data grid and caching for creating a scalable solution and why it is not an afterthought. Okay, so in today's modern architecture, caching is a first-class citizen. You don't have to think about caching after you see your performance test results. To be honest, you have to start thinking about caching as a first-class citizen because it not only improves the performance, but it also improves the resiliency of your application, scalability, availability, and entire user experience because users get the faster response time. So caching, it not only applies to just reducing load on your backend system, but also Forrester coined a term translytical architecture where we are basically saying using caching as a data platform. So the caching is evolving, and as you can see in the diagram, the caching has become the core concept. Around that, there is an ecosystem evolving in the form of in-memory data grid computing and all. So let's look at specifically about in-memory data grid as a solution option. In-memory data grid is more than caching. It's providing the you can say a grid computing based architecture, a suite of nodes which are accumulated together to create a data platform. So this technology started getting popular in 2011. And nowadays it's in full productivity as every technology goes through. And I'll just share a quick example where we can see that how you can achieve caching and in-memory data grid as well as the business expectation. And this is an example of how and shared in Hazelcast website where a particular client has gained almost 1.2 microseconds. We are not even talking milliseconds, it's microseconds, kind of a latency in an application using the caching and in-memory data grid. The other example of where caching or in-memory data grid have been very useful, and there are many use cases and case studies you can find. I just want to mention some of the key ones where I saw a retail banking application where the response time got almost 20 times faster. An insurance client, which is using a lot of content web sessions, they started using in-memory data grid products for storing the session data, and they saw that increase in performance and all, and a mobile service provider using data grid for personalization and billing information. So there are many such examples where you can see that people have achieved scalability and performance both using the in-memory data grid and caching. So let's look at some of the caching architecture patterns. So caching, as you know, if I apply it into a layered architecture, you can apply it virtually at any tier, whether it's client tier, web tier, gateway tier, service tier, or storage tier. So there are definitely different technologies which you can use at each tier. Like if you're doing at an edge caching, you will use CDN. If you're doing it at a gateway API layer, you will use gateway caching. If you're using a service tier, you will use some in-memory data grid or caching technology. Or at a database layer, again, database systems also have their own caching kind of implementation, but you can also cache the database results in in-memory data grid. So when you are considering caching, these are the four factors which you need to consider. What to cache, what data you need to cache. So first thing, before getting into the solution, you need to figure out that what I'm doing with the caching solution, what data I need to cache. And then you need to start figuring out where to cache. Where to cache is which location, which component, where, which tier, where I'm caching the data. And then the question comes about the technology, how you're caching the data, which caching topology you're going to use, what are the techniques you are going to apply. And the last bit is when are you going to cache it? How long? What is your TTL? That's very important perspective that when you're thinking about caching, you think about in these four dimensions. So when it comes to applying caching architecture pattern, and that's my list of 3 key patterns, and I know there are many such patterns which are evolving these days when it comes to in-memory data grid or in-memory caching. The pattern A is using the in-memory data grid as a horizontal layer at an enterprise caching layer. Pattern B is where you have micro cache supporting the microservices kind of architecture or event-driven architecture. And the pattern C is where you're doing the native database caching. And we'll talk about these patterns. So in pattern A, what we are doing is we have a common, you can say a caching grid, which is consistent of many different nodes. When I say nodes, it's virtual machines or any compute machine. So it's a cluster of all these nodes together, and then they are providing a grid component with a very high available, highly scalable micro millisecond response time. So if you want to cache the data from an application standpoint, all you need to do is you can put the data in the grid and the data gets taken care of by the caching cluster. So again, there are different patterns and strategies which you can use, like whether you want to use distributed caching, you want to use replicated caching. These are the different deployment topologies. And then your different strategy, whether you want to apply read through cache, write through cache and all. But the key theme is that you have a caching layer which is sitting on top of your storage or database layer. The second pattern is where you don't want a more like a grid or you can say a cluster, but what you want to do is you want to use micro caching to improve the performance of your microservices. And this is particularly useful if you want to individually scale and see how that service, how I can improve the performance of a particular service. So you can use a small caching component as part of each service, and then each service manage their cache effectively, but there is no data sharing between services, or you are not going to get the same level of scalability which you get in the pattern. And pattern C is pretty much doing the caching at the database layer. So database layer nowadays, whether it's SQL or NoSQL, they provide in-memory caching facility as well. You can leverage that. So pattern C is all about using native database caching. The only downside of this is they are limited to the product itself, and also you don't have any visibility into what's happening inside the caching. It's complete, you can configure it, but it's completely driven by that particular database technology. So now that we have seen all three patterns, here's a quick decision tree which you can use for determining that what kind of caching pattern you can apply. If you're, for example, if you're using application caching, my recommendation is go for pattern B or micro caching or data grid caching if you're looking for a scalability. If you are just looking to cache the data elements, then you can go for database level caching. If you want to do the application state storage caching, then you can go again for pattern A and B. So this is just a simple guide which you can use it for applying these patterns. So now that we have seen different caching patterns, and I just want to highlight some of the key providers which you can use out of the box so that you can implement your caching or in-memory solution quickly. So if you look at the big three cloud service provider, AWS, Azure, and Google Cloud, they all provide managed service when it comes to caching. AWS provide Elastic Cache for Redis and Elastic Cache for Memcache. Azure does the same for Redis and Memcache. And Google Cloud also has Memory Store, which does provide a managed service. So if you don't want to manage the infrastructure overhead yourself, you can use one of these cloud service providers offering for your application. The other way of implementing caching is by using caching vendors. They are a specialized vendor. They have been working on caching systems for a long, long time. Most of them provide their own cloud implementation, and they can help you deploy their solution in AWS, Azure, or Google Cloud. And they have partnership with all three cloud service provider based on your preference, right? So Redis, Gigaspace, GridGain, Hazelcast, Oracle Currents, all are big names in the caching vendor and in-memory data grid vendors. So they are very specialist. So I would definitely recommend to evaluate these vendors, and each vendor has certain strength and growth areas. So it all depends on the use case where and what you're trying to use. So having said that, I'll just quickly share what you can achieve out of caching and in-memory data grid. And here are a few examples I've taken from as a reference architecture. The first example is from Hazelcast itself, where they have created a compute platform using the caching, where the data grid is sitting in between and with the data store, and the computing is also powered by the caching solution. So as you can see, caching is not only just temporarily lived data. You can also use it for ingesting, processing the ingestion and computing of the data in motion. So that's an important aspect of this reference architecture. The second reference architecture I want to share by Gigaspace, which is very useful, again, creating a big data kind of platform where caching is supporting data visualization, data analytics, and microservices applications and everything. So you can create that in-memory data grid, and it can take care of all the different storage needs. So one thing which I would say that, caching nowadays is not just or in-memory data grid, I would say it's not just providing a temporary storage. It's a reliable storage. You can use it for any data processing, considering the availability and scalability it provides and resiliency it provides. So thank you so much for doing this session, and feel free to share with your friends and colleagues, and feel free to reach out to me on my social media channel, Twitter and waitcraft.com. Thank you so much.